Welcome back. Today we're going to talk about rotations. So a rotation is a transformation that turns a figure around a point. Whereas in reflection we had a line of reflection, in rotation we have a center of rotation. Okay, so we're just looking at a single point, not a line. And in 8th grade, your center of rotation is always going to be the origin. When you take geometry again in 9th or 10th grade, there will be other centers of rotation, but for us, we're going to really mainly focus on the origin as the center of rotation. So what's always implied in the questions that you have is that the center around which we're going to rotate the objects is the center called the origin, or the coordinate 0, 0. Okay. So, for instance, you can tell that this blue figure is the pre-image. Remember, we can always tell the pre-image because it doesn't have the primes on it. And then the green figure has been rotated 90 degrees from the image to the pre-image. And I actually know that it's been rotated 90 degrees because this is how I can always check. If I connect, let's say we're interested in A. Vertex A. If I connect A to the origin, and if I connect A prime to the origin, what I'll notice is that these right here create a 90-degree angle. So anytime I connect a vertex to the center of rotation and the corresponding vertex to the center of rotation, that always creates a 90-degree angle. I could do the same thing. Let's say that I want to do a different color here. If I connect B prime to the origin and I connected B to the origin, that also creates a 90-degree angle. Or let's say I could also do it with C prime here. So I connected C prime to the origin and then C to the origin. This right here is a 90-degree angle. Okay, whoops, I should put a little square in it. So that's how I can always tell that it's a 90-degree rotation, because a vertex connected to the origin, or the center of rotation, and the corresponding vertex connected to the center of rotation, that creates the angle by which the object has been rotated. Okay. Now I just wanted to remind you again that circular motion is either labeled clockwise, so if it goes in the direction in which the hands of a clock move, that's called clockwise, or CW. And counterclockwise is the motion against which the hands of the clock move. So if it moves in the opposite direction by which those hands move, that's called counterclockwise, often abbreviated as CCW. And remember, sometimes that's called anti-clockwise. The degrees that we're going to rotate in 8th grade are 90, 180, 270, and 360. So we're only going to go in multiples of 90 degrees. And we have to be specified to go in either the clockwise or the counterclockwise direction, except for the two angles 180 and 360. And I'll tell you why I don't need to specify their motion in just a minute. It'll be in one of the examples. Okay, anytime a figure is rotated 90 degrees clockwise, either clockwise or counterclockwise, anytime it's rotated 90 degrees, every 90-degree rotation flips the coordinates. So for instance, if we follow the path of C as it rotates 90, 180, and 270, C started out as the coordinates 7, 2. And if I rotate from the blue to the green, a 90-degree rotation, C prime becomes -2, 7. Now, what I mean is that what was once the X and the Y, the magnitudes. Now remember, a magnitude is just it's like it is the absolute value of the number. So the absolute value of 7 and 2, those switch around. Now 2 does take on a negative sign because this is the pre-image was in quadrant 1 and the image was in quadrant 2, but the magnitudes switch around. So what was X before became Y, and what was Y before became X. So with every 90-degree rotation, your X and Y coordinates switch around. Now, with the second rotation, this magenta figure right here represents 2 90-degree rotations from the original pre-image. So this lands in quadrant 3. Okay. Now, in quadrant 3, both the X and Y values are negative, so C double prime becomes -7 and -2. Okay. So what you'll notice is that the 7 and 2 flipped around to get 2 and 7, essentially. Those are that's the magnitude of the values here. And then they flip back around to get 7 and 2 again. Again, I'm just referring to the magnitude, not the sign of the numbers here. Okay. And then if upon another rotation of 90 degrees, C triple prime becomes 2 comma negative 7. So again, it's just, if we think about 2 and 7 flipping from the original 7-2 to 2-7 to 7-2 to 2-7, every 90-degree rotation flips the coordinates. Now, in order to rotate a figure, what we're first going to do is we're going to use the rules to find the magnitudes of the new coordinates, okay, essentially trying to figure out how many times it's flipped around. If it's rotated either 90 and 270, the x and y stays flipped around. So for instance, you'll notice that in the 90-degree rotation, the magnitudes are flipped around, and the 270-degree rotation, the magnitudes are flipped around. That's what I mean by this, that xy becomes yx. If it's rotated 180 degrees, the magnitudes of the coordinates stay the same. So what was originally 7, 2 becomes -7, -2. So the magnitudes 7 and 2 stay in the same position. Okay, whoops. So 90 and 270 flips and 180 doesn't. And then after we find the magnitudes of the coordinates, we're going to think about what quadrant it lands in, and think about putting signs in with the magnitudes of the coordinates depending on which sign, which quadrant the image lands in. So if we started, for instance, in quadrant 4, we had a point here, and I asked you to rotate it 180 degrees, well, I know that the x and y values wouldn't change, but the signs, or the magnitudes of the coordinates wouldn't change rather, but the signs would change. So what was 2, let's see, this is 2, -3 before, would become 2, 3 over here. But except it's going to be -2 and +3 because the x and y, the x is negative in quadrant 2 and the y is positive. All right, so let's actually try one of these out. Okay, I want to rotate this quadrilateral counterclockwise by 90 degrees. Now, counterclockwise means that it's going to land in quadrant 2. Okay, so all the original magnitudes are going to switch because it's a 90-degree rotation. So A was 1, 1. A is now, A prime is going to become negative, it's going to have magnitude 1 and 1, but since it's in quadrant 2, all the x's are going to be negative and all the y's are going to be positive. Okay, so A becomes -1, +1. That's A prime rather. Okay, what B originally was 1, 3. So B prime is going to be, let's switch the order, 3, 1, but make the x negative. So it's going to be -3, +1. Okay, C was originally 3, 2. So C prime is going to be 2, 3, and then we're going to make the 2 negative. So -2, +3. And then D was 3, 1. And this becomes, D prime becomes 1, 3, but we're going to make it negative. So -1, +3, that's D prime. Okay, and then let's connect these right here. Whoops. Okay, so this is the figure that's been rotated 90 degrees. Now, what you will notice is that, let's just focus for a second on line segment DC. Line segment DC was a vertical line before, okay? Now this vertical, I know that it's been rotated because this vertical line has been rotated to become a horizontal line. The vertical line in the pre-image becomes a horizontal line in the image. That's how I know it's a 90-degree rotation. So if I did that trick again where I connected points, so if I connected, let's say, C prime to the origin, the center of rotation, and C to the origin, they make a 90-degree angle, right? This angle right here is 90 degrees. I could do that with B and B prime, right? And again, those always make 90 degrees. That's how I know it's been rotated. Okay, let's try another figure. So here, I want to rotate this clockwise by 180 degrees. Now, what you'll notice is actually, if I don't even have to specify that it's clockwise. all I have to do is actually just tell you 180 degrees, because if I rotate 180 degrees clockwise, it becomes in quadrant 4. If I did it counterclockwise, it goes to the same quadrant. So it doesn't matter which direction you go in, 180 degrees will always end up in the quadrant that's diagonal to the one that you started in. So it starts in 2, it ends up in 4. Okay, so what was A before now? So A was negative 3, 4 before. So A prime becomes, so I want to keep the same magnitude, the magnitudes in the same order, but in quadrant 4, it's a positive x and a negative y. So I have 3, negative 4. So positive 3, negative 4 would be my A prime. My B was 6, negative 6, 3. So my B prime becomes 6, 3. Those are the magnitudes, but my y is going to be negative. So I have 6, negative 3. That's my B prime. My C was negative 4, 2. So my C prime is going to be 4, negative 2. So 4, negative 2 right here. And then my D is negative 2, 3. So my D prime is going to become, let's see, 2, negative 3. So 2 and negative 3. This is my D prime. Okay. And here's my figure. And I should put my A prime out so I can, right? Right, so the whole thing has been, and actually you know that it's 180 degrees because anytime I connect a point, the original point from the pre-image to a point from the image, it actually creates it creates a straight line, which is a 180 degree angle. So essentially if I connect D to the center of rotation and D prime to the center of rotation, it just creates a straight line, okay? And so the whole figure has been rotated that way. Okay, finally, the properties of rotations are that the image and the pre-image are congruent. They take up the same area. But what you have to understand is that the orientation, which is the way that the vertices look, or the way the figure looks, has been changed. So for instance, let's just focus for a second on line segment AE. So line segment AE right here, A was directly above E in the first, in the pre-image, but A prime E prime is not the same, is not directly above, A prime is not directly above E prime in the image. So the orientation has been flipped around, or it's been rotated rather. In a reflection, the orientation flips, either left, right, or up, down. In a rotation, the orientation rotates with the figure. So what was directly above another vertex before is now to the left if it's a 90-degree rotation or a 270-degree rotation. And even in a 180-degree rotation, a 180-degree rotation is the same thing as flipping across a vertical line and a horizontal line. Okay, so the images are congruent, but the orientation is not preserved, and the position is also not preserved. And that is the end of the lesson for today.